In this question, we are talking about a factory makes lamps. The probability that a lamp is defective is given as 0.05 and a random sample of 30 lamps are tested. Find the probability that there are at least one defective lamp. So in order to do this, so let us describe this given random variable. So x is a discrete random variable, which let us assume that this one is going to represent the number of defective lamps. So which is distributed binomially with the value of n, which is the number of trials being 30, and the probability that it is defective is nothing but 0.05. And whenever we need to find out the probability of x is the random variable is equals to some particular value, so that thing I can do it always using the formula of NCR into p to the power of r into q to the power of n minus r. So in that case, for part A, we need to figure out what is the probability that at least one of the lamp is defective. So which means we need to check that the random variable x represents the number of defective lamps, is greater than or equals to 1. So one way is we have to do it from 1 to 30. So that's a lots of work. So I'll be doing it like 1 minus probability of x is less than 1, so which is nothing but x is equals to 0. So 1 minus there are no defective lamps. So in that case, this is going to be 1 minus. If I need to figure out the probability of x equals to 0, I will be using this formula. So it is going to be n is nothing but 30. So 30C0 into p is nothing but probability of success, which is nothing probability that it is defective. So 0.05 to the power of 0, and q is nothing but probability that it's not success. So which means it's going to be 0.95. So 1 minus p, 1 minus 0.05, which is nothing but 0.95 to the power of 30, because it's n minus r, n is 30 and r is 0. And when you simplify this, we will be getting the final answer, something like 0.785. So this is the right answer for part A. Now for part B, given that there is at least one defective lamp, find the probability that there is at most two defective lamps. So this has something to do with the conditional probability as well. The conditional probability formula would go something like probability of whenever we have A given B, so that's going to be probability of A intersection B divided by probability of B. So here we are talking about the given is at least there is one lamp in the sample is defective. So this will be my event B, and the probability that there are at most two defective lamps. So that means we need to figure out in this sum what is the probability that at most 2 means x is less than or equals to 2, given that x is greater than 1, greater than or equals to 1. So that represents the at least 1. So in that case, it's going to be probability of x must be greater than or equals to 1. So I'm just writing it in a reverse order, and x must be less than or equals to 2, and divided by probability of x is less than or equals to 2. So when I say x must be greater than or equals to 1 and less than or equals to 2, so that means it must be probability of x equals to 1 or probability of x equals to 2 for the numerator. And for the denominator, it is not x is less than or equals to 2, because we are talking about event p, which is nothing but x is greater than or equals to 1, which we already found. For the denominator, it is just going to be 0.785. So in that case, if I calculate the probability of x is equals to 1, so I can use this formula. So in that case, in place of r, we have 1. So that's going to be 30C1. P is nothing but 0.05 to the power of 1. And Q is nothing but 0.95 to the power of 30 minus 1, which is 29. Plus probability that x equals to 2 would be 30C2 into 0.05 to the power of 2 times 0.95 to the power of 30 minus 2, which is nothing but 28. And this entire thing divided by 0.785, And when we simplify this, we will be getting the final answer to be something around 0.761. So that is the right answer for this sum.